Welcome back. We're going to wrap up the elevation of boiling point concept with a math problem. But before we do that, I do want to come back to that figure that I showed you in the previous video and just recap it really quick so that it's kind of a summary of it. So between A and B, it's continuing, it stays in the ice phase. Okay, so this is where it's really melting and it's freezing. There's an equilibrium. So here it's purely water, and it continues to stay in water. So this is when it's actually boiling. This is when it's actually condensing in the reverse process. And then this is just steam. Okay, I just want to point that out. So that you not only understand the class, but you're much more technically superior. Okay. All right. With that said, let's put up the problem. So let me get out for just a second. Pull this down a little bit, and then put it back up. All right. If 2.5 grams of sodium chloride is dissolved in 100 grams of water, if the solution is boiled, what is the elevation and boiling point? And Kb is given, and here is all the equations. You do not have to remember the equation. It's actually asking for Tf, okay? It's asking for this value, okay? What's the boiling point? Actually, elevation of boiling point is just delta Tb. What is the actual boiling point is Tf. So NaCl is a metal compound, metal containing compound. In other words, it's also ionic. So I equals 2. How do I know it's 2? This is 1 and this is 1. I have 1 of Na, 1 of Cl, so I is 2. Okay, Kb is already given. You do not have to convert or anything. It's already there. I is 2, I know that. So if I can calculate molality, I'm pretty much done with the problem. What is M? Molality. What is molality? It's moles over kilograms, right? So I know 2.5 gram of NaCl. I got to cut the moles of it. So I think sodium is 23, chlorine is 35, so it's 58 grams over 1 mole. As I said, all of this stuff is very, very easy. There's nothing, doesn't require you a whole lot to do, so it's 0.043 moles. And I have 100 grams of solvent, right? So 100 grams to kilograms would be 0.100 grams over 1,000 grams over 1 kilogram is 0.1 kg. So this molality would be 0.043 over 0.1 will be 0.43. So let's put all this together. So the elevation of boiling point is delta Tb, which is Kb, which is 0.512, times molality is 0.43, times I is 2. Now, if this were a non-metal containing compound, it doesn't matter. If it doesn't contain a metal, I is just 1 for the entire compound, okay? So elevation of boiling point is times 0.43 times 2, which is 0.44 degrees Celsius. This is the elevation of boiling point. But what is the actual boiling point of the liquid itself? Well, you have to add this value to 100. So Tf equals 100 plus delta Tb. This is how much it's elevated. But what is the actual boiling point is, because we're heating it with water, 100 plus 0.44 is 100.44 degrees Celsius. Now, there's a common myth that says if you add salt to your water is going to boil faster. Let's break that. That's a myth. There's no such thing. In fact, it will only take longer, as in this case. Okay, I just add a table salt to water. instead of 100 degrees, it actually boils at 100.44, which means definitely it's not going to boil any quicker than you might think. All right, so that's the end of elevation of boiling point. I'll see you back with freezing point.